All right, so today we're diving into something big. We're going to look at a single day, September 8th, 2025, that basically marks a huge turning point for the entire world of AI. I mean, everything is changing, and it's all happening right now. So here's how we're going to break this all down. Think of it like a five-act story. First, we'll see how AI basically hit a wall. Then, we'll look at the mad dash to get more efficient. After that, we'll explore how the models themselves are getting smarter, not just bigger. Then, of course, we'll follow the money and the power plays. And finally, we'll see how society is stepping in to write some new rules for all this crazy powerful tech. All right, let's get right into it. Part one. This is all about the moment the AI industry, which, seemed like it could grow forever, just slammed headfirst into a very, very real wall. For the longest time, the playbook for making AI smarter was super simple. Just throw more computing power at it. More GPUs, bigger models, right? Well, according to this market brief, that whole era, it's over. Done. The brute force approach just isn't working anymore. The party's officially over.
So what does that actually mean, hitting a compute wall? Well, the technical term is compute saturation, but really, you can just think of it like a global traffic jam for data. All the big cloud companies, they've basically run out of GPU capacity. GPUs are those super powerful chips that are the engines for AI, and there just aren't enough to go around. It's a massive, massive bottleneck for pretty much everyone.
But you know what they say, right? A crisis like this, it forces people to get creative. With that old path of just make it bigger totally blocked, the whole industry has had to pivot. And now it's a desperate race for efficiency. And we're seeing the response come from three different directions. Okay, so the first front in this race is all about the hardware. It's a very physical, very real problem. These AI data centers are absolute power hogs. They're so hungry for electricity that they're literally putting a strain on global power grids. You can't just keep building more of them. It's just not sustainable. So what's the solution? Well, check this out. Researchers have come up with something pretty radical, a whole new kind of chip that actually computes using light instead of electricity. And the result? It's a jaw-dropping leap forward. We're talking up to 100 times more power efficient than the traditional chips we use today. And how it works is it's wild. So first, it takes the machine learning data and turns it into laser light. Then that light zips through these tiny little lenses on the chip to do the actual calculation. And then finally, it turns the result back into a digital signal. And the craziest part, it does all this using almost zero energy. This isn't just an improvement, it's a total game changer. But hey, it's not all happening in the hardware. The second big push in this efficiency race is on the software side, at the code level. It's all about designing new algorithms that work smarter, not harder. And a perfect example of this comes from a Japanese company, NTT. They've developed this technology that speeds up data analysis by a mind-blowing 73 times. So how they do it? Well, instead of just crunching all the numbers, their algorithm intelligently prunes or cuts out the unnecessary data before it even starts the calculation. It's like telling the AI, hey, ignore all this junk, it doesn't matter. It's basically a massive software shortcut. And that brings us to the third response. Just stop sending every little piece of data to those overloaded cloud data centers in the first place. The new strategy is to bring the computing power to the source, what we call the edge. And they're doing it with these tiny, super efficient chips, like this Metis M2 Max, that can run really complex AI models right there on your device. Okay, so all these incredible gains in efficiency are having this massive ripple effect. And that leads us straight into our third act, how the AI models themselves are evolving. Now that the obsession with just being big is over, models are being forced to get smarter in much more interesting ways. And if you look at the latest flagship models, you can see this whole new battlefield emerging. I mean, OpenAI's GPT-5 isn't just bigger, it has a special model just for reasoning. Meta's Llama 4, it's got a crazy 10 million token context window. And Google and Anthropic are adding things like deepthink and extended thinking modes. The competition isn't about size anymore, it's all about having specialized skills. And all of these new skills, they're all pointing toward this really important new idea called agentic AI. And this is a huge deal. We're talking about a fundamental shift away from AI as just a passive tool that answers your questions. We're moving toward AI systems that can act like autonomous teammates. You give them a high-level goal, and they can actually make a plan and go execute it.
So, with all this tech being rebalanced, you can bet it's making some huge waves in the business world. Money, power, corporate strategy, it's all shifting to keep up with this new reality.
And the money is definitely following. Venture capital is just flooding into this new AI landscape. Take the AI coding startup Cognition. It just hit a mind-boggling $10.2 billion valuation. Or look at Europe. AI startups there have already raised over 6 billion euros this year. That absolutely blows past what they raised in all of last year. The investment is just on fire. We're also seeing this really fascinating new power play emerge, vertical integration. So ASML, the company that literally makes the machines that make the computer chips, they just went and invested over $1.5 billion directly into an AI model company, Mistral. Think about that. The hardware world is buying its way into the software world to make sure they have a seat at the table in this new ecosystem. And if you want a truly wild strategy, just look at what OpenAI is doing. Instead of just trying to sell their tech to Hollywood, they're actually funding an entire animated movie called Critters. Why? To prove that AI can help make films way faster and cheaper. It's not just a sales pitch, it's this huge, flashy demonstration designed to basically hack the adoption process in one of the world's biggest industries. And finally, as AI gets this powerful and woven into the fabric of our world, you've got society starting to catch up. We're moving past the stage of just promises and voluntary commitments and into an era of actual legally binding rules. And the biggest development here is California's SB 53 bill. This thing is a landmark piece of legislation that's really setting a new global standard. It's smart too. It's carefully targeted, so it only applies to the most powerful models. You know, the ones trained with a massive amount of computing power. But for those models, it gets really serious. We're talking mandatory reporting for safety problems, protections for whistleblowers, and, for the first time, real financial penalties if you break the rules. It even creates a public cloud to help smaller researchers stay in the game. So what does all this really mean? It means the whole game is changing. We're leaving behind the old way of doing things. Where companies just made voluntary safety promises that weren't really binding. And we're moving into a new era of actual legal obligations, with real, tangible consequences if you don't comply. So, when you step back and look at the whole picture, the new chips and algorithms focused on efficiency, the smarter models that are more specialized, the big money moves, and the new laws, it all tells one single coherent story. This is the great rebalancing of AI. It's a pivot away from that singular obsession with just scale and toward a much more mature strategy built on 3 pillars: efficiency, specialization, and regulation. And all of that leaves us with one last, really crucial question to think about. As AI goes through this great rebalancing, is it possible that its biggest challenge isn't about building more intelligence anymore, but about learning how to manage the incredible consequences of the power we've already created?